Hey there, Joey this side. Welcome to Joey's Tech. In this video of Joey's Tech, we are going to look into another interesting problem, which is to find the number of endless points. This is also a matrix problem. Before we see the problem statement, I want you to subscribe to my channel if you haven't done it yet and hit the bell icon, because that way you will get notified whenever I release videos like this in future. Also make sure that you watch this video till the end, because doing so will help you add another interesting problem, another frequently asked problem to your list of dynamic programming problems. Now let's see the problem statement. So the first statement of the problem is that you are given a matrix of n by n dimensions. So it's a square matrix. That means that if there are 4 rows, then there will be 4 columns in the matrix only. And if there are 3 rows, then there will be 3 columns in the matrix only. You need to find the number of endless points in this square matrix given to you. Now, one important thing is that if you are standing at one cell, then you are only allowed to move either right or down in this matrix. So the ask is that you need to find the total number of endless points in this matrix. So the obvious question that you are going to ask me is what is an endless point? Let's find out what an endless point is using this graphical representation. So this is the matrix that we are going to work upon to find the total number of endless points. Now, for a cell to qualify as an endless point, first of all, it has to be 1. All right. Now, this particular cell cannot be an endless point because it is 0. Only the cells which have the values as 1 can qualify to be an endless point. The second condition is that, let's consider this cell where I have put 1 in this circle. So if we move right from here till the end of the matrix, then you can see that all the subsequent cells contain 1. So when we are moving right, that means we are going column wise, then all the cells contain 1 till the end. And when we are going to move down, that means row wise, so you can check till the end of the matrix, all the cells contain 1. So this is the second qualification of an endless point. So number 1 is that the cell must contain 1. Number 2, that whenever we move right or down from that particular cell till the end of the matrix, we must get all ones. Another example of an endless point is this. See, this cell is 1. If we move right, we are getting 1, and then it's the end of the matrix. And when we move down from here, we are getting all ones till the end of the matrix. So this is also an endless point. We need to find how many such endless points exist in this matrix. That means the total number of endless points. So let's move to the framework where we are going to find the total number of endless points using the dynamic programming technique. So here is our framework where I have put down our 4x4 matrix. Now one solution, which is the naive solution, is that I move cell by cell from the starting point to the ending point of the matrix, and then at each cell I go right as well as down and find out if it is an endless point, count such endless points and give the total result. Now that is going to give me the results when I am working on a 4x4 matrix, but imagine if I am working on a 1000 by 1000 matrix, then my program is going to run forever. So we can't use it. We are going to apply the dynamic programming technique over here. So how can we do that? Let's see the approach. So let's say if I am standing on this particular cell, okay, this is an endless point, that's why I'm starting from here. Okay, so when I think of dynamic programming, then I just have to check if the cell on the right is 1 or not. So this is the cell to the right of this cell. Yes, it is 1. All right, there is a possibility. Also I have to check if the cell below it has 1 or not. So this cell also has 1. So now there is a possibility that this particular cell is an endless point. Now the execution has to move here and I have to do the same check. If the cell to the right of it has 1, yes, it has 1. And if the cell to the bottom of it has 1, yes, it also has 1. So there is a possibility for this particular cell to be endless as well, to be an endless point as well. Okay, I come over here and there is no cell on the right. So what I can do, I can simply send out a signal to this cell as well as this cell that yes, you two are endless points when the right direction is concerned. Similarly, when I have reached this cell and there is no cell to check below it, then I can send a signal to this point as well as this point that you are endless from the downward direction as well. So this is one solution. But to make it more optimized, what if instead of moving left to right, what if I start from right to left? So if I start from here, okay, so there is nothing over here, so I can mark it as endless because there is nothing in front of it, and I can move here, and based on this cell's value I can mark it endless as well when the right hand side direction is concerned. Okay, simply I move to this cell, and if this is endless then I can mark it endless as well. Also, if I start from bottom to up, then there is nothing below it, so I can mark it as endless, and I move one cell up, and based on this value I can mark it as endless. And if I move above further, then based on this value, if it is endless, then I can mark it as endless as well. So there are two components when a particular cell is concerned. One signifies the right hand side direction and another one signifies the downward direction. Hence, it would be much easier if I created separate matrices for these two components. So I'll be having a matrix for the right hand side component, and I'll be having another matrix when it comes to moving down from a particular cell. So let's start filling this matrix, and for this we are going to start from right and proceed to left for each column, and here we are going to start from the bottom and move up for each row. Okay, so I'm going to start from here. So I have 1 and there is nothing in front of it. Okay, so it's endless, so I'm going to put E over here. Now let's talk about this one. So this is also 1. So all I have to do is check the previous value here. It is endless. Okay, so I'm going to mark endless over here as well. Okay, and I'm reiterating that I'm marking this particular cell as endless only from the perspective of moving right. Okay, that means it is endless in the right hand side. All right, now we move to this cell. Here everything stops. Okay, this is 0 first of all, and the number one eligibility for a particular cell of being endless is that it has to be 1. So here I'm going to simply put 0. Okay, now I move over here. So here I'm going to find 1. Alright, so I just have to check what is the value of the previous cell. It is 0, so it can't be endless in the right hand side. So I'm going to put 0 over here. Alright, now I'm going to start from here. So here I'm again getting 1, and I will have to mark it as endless because there is no cell on the right hand side. Alright, now I move here. So what does the previous cell contain? So it contains E. Alright, and this is 1, so I am going to put E over here. Cool. Now I move here. Now I need to find the value of this cell. So here the value is 1, so the first criteria is satisfied, and I have to check the cell before it. So it also gives me E, so I'm going to put E over here. Okay, now I move to this cell, so the value corresponding to it is 0, so the first criteria itself is not satisfied, so I'm going to put 0 over here. Okay, now we are going to find the value of this cell. Here also it is 1, and there is no cell next to it on the right hand side, so I am going to put E over here. Now let's find the value of this cell. So here also it is 1, first criteria is satisfied. What is the value before it? It is E, so I am going to put E over here. Okay, now here again I have 1 and the value on the right hand side is E, so I'm going to put E over here again. Now over here also the value is 1 and the value in the cell on the right hand side is also E, so I'm going to put E over here. Now let's talk about this cell. So over here the value is 0. Alright, so I'm going to put 0 over here. It is not endless. Okay, the first criteria itself is not satisfied. That is why I'm putting 0 over here. Over here I am getting 1. So my first criteria is satisfied. Now I have to check the value of the cell which is on the right hand side. It is 0. So I'm going to put 0 over here. Now for calculating the value of this cell, let's check the corresponding cell in the problem matrix. It is 1. First criteria is satisfied. So let's check the value of the cell on the right hand side. So it is 0. So I'm going to fill this cell with 0. The last cell has the value as 0. So first criteria is not satisfied. So I'm going to put 0 over here. So this completes my right hand side matrix. Now let's move to filling this matrix, okay, which concerns with moving down from a particular cell. So like I said, we are going to start from the bottom here. So let's start from here. Okay, so this is 0. All right, so I'm going to put 0 over here. The first criteria itself is not satisfied. Now let's talk about the value of this cell. The corresponding value over here is 1. So first criteria is satisfied, but the value before it is 0. So what I'm going to do, I'm going to pass 0 over here. Okay, now the corresponding value over here is 0. So I'm going to put 0 over here. Okay, this value is 1. So the first criteria is satisfied, but the value of the cell just below it is 0. Hence I'll put 0 over here. Now let's start from here. Okay, so the value over here is 1 and there is nothing below this cell, so I can mark it as endless. Okay, let's talk about this cell. So over here the value is 1. Let's check what is there in the cell below it. It is E, so I'm going to put E over here. Good. Alright, so over here we have 1. The first criteria is satisfied, and what is the value of the cell below it? It is also E. So E comes here, E passes up, and for this cell the value is 0, so I'm going to put 0 because the first criteria itself is not satisfied. Now let's move to this cell. You have to notice that we are moving row wise here, and in this matrix we moved column wise. Alright, from here we again have 1, so I'm going to mark it as E. Over here I have 1, so I'm going to again mark it as E. Over here I have 1 again, so I'm going to mark it as E, and over here I have 1 again, so this will be E2. Alright, now let's talk about this cell. So over here I have 0. So 0 goes straight away in here. It is not endless. Now over here the corresponding value is 1, but the value of the cell below it is 0. So I'm going to put 0 over here. Similarly, all these will be 0. So this matrix is also complete and full. Now all I have to do is find out the common endless points from here. That means the cells which contain E in both these matrices. Okay, so let's find out which are those cells. So you can see that I have marked all the cells which contain E in both the matrices, and I have color coded them just for proper visualization. So all I have to do is count these cells, and that is going to give me the total number of endless points in this 4x4 matrix. So I can see that the total number of endless points is 5, and that is our answer. So with this we have come to the end of this video. I hope you enjoyed watching this video. I hope you were able to grab the approach that I explained in this video to solve this problem. I look forward to help you with programming and algorithms. And only for this video. Goodbye and take care. And keep watching the videos of Joystick.